Welcome everyone to the IoT Developer Series. We are going to start in a minute, so we give people some time to join this session. So welcome again. Let us know where you're calling in from. Always curious to hear that. And we'll be starting soon. I see some familiar names popping up. So it's a series. So this is actually the fourth workshop that we're hosting. It's great to see also some names coming back. And also for the ones that are joining in here for the first time, welcome. Great to have you joining in. It's a great start of the day to kickstart your cellular IoT journey. Let me start sharing my screen and then we can dive in. So this is part of the IoT workshop series, Cellular Kickstart Your Cellular IoT Journey. And today specifically, we are focusing on integrating and acting on cellular IoT data. And I'm very happy to have with me Ubidots David, who is an expert in this field. He's been working on IoT and IoT platforms for many years already. So I'm really happy that that he's joining in and that he's able to help us out during this webinar. David, you want to say a few words to introduce yourself?
Definitely. I think I would like to start by thanking you for the invitation. I already told you that it's been quite some time since the last time I joined to a webinar. So I'm really excited to present all the content we have for you today. A little bit about me. My name is David. I come from Colombia, and I work at Ubidots as the head of customer success, right? That is basically making sure that all of our support operations from lead pre-sales process and to the making sure our customers make the most out of Ubidots flows in the right direction. So yeah, excited to be here basically.
Great. Well, great having you here, David. So we're gonna hear much more of you later on. And for the ones who don't know me yet, so my name is Lawrence. I'm the developer community manager at Monogoto. And Monogoto is an MVNO, a mobile virtual network operator. We'll dive more into the technical details, but basically, when you have a Monogoto SIM, then you directly have access to 500 cellular networks around the globe. So today's program, for the ones that are new here or have not been participating in all sessions this far, I will be giving a short recap on cellular IoT and give a few highlights on the content that we already covered in the past weeks. Then we dive into IoT platforms. So what is it? What's the role and how to choose one? We learn more about the networking protocols. So I know there are so many different options you choose from. So we're gonna discuss the few popular ones in detail. And finally, we end with a live demo. And if you have any questions in the meantime, feel free to add that in the chat or in the Q&A section, and we'll be addressing them live at the end of this session. And after the session, if you still have any questions or want to engage with us, people from Monogoto or other IoT developers, then I'd warmly welcome you to engage on the Monogoto community forum, which is the central place for all support questions and to help each other out in this challenging IoT world. So let's first dive into cellular IoT and what this exactly is. And here we're going to take a few steps back and focus on the release of the 4G specification in 2008. And something interesting happened in 2008 because there was not one single technology being pushed. No, instead there were actually two different technology standards being released at that moment. And at the one end, we had LTE CAT-M1, which is part of the MBB or the mobile broadband. And at the other end of the spectrum, we had LTE CAT-M1, and that falls within the MTC or machine type communication. And the difference is that mobile broadband, it focuses on high data throughput, large bandwidth, and very low latencies, allowing us to stream Netflix or Spotify wherever we are. And machine type communication mostly focuses on the connecting IoT devices to the internet. So we dive into reducing cost, because IoT devices often come in large volumes, and we focus on increasing link budgets to increase the range. And also one of the most important features is reducing the energy consumption, because almost all IoT devices run on batteries. And then we see that there are three popular cellular IoT standards today. And the first one is LTE CAT-M1 or CAT-M1bis. The second one is LTE-M, and the third one is narrowband IoT. And the main reason, I would say, two main reasons to go for LTE CAT-M1 is, well, it has the highest throughput of the three technologies. And mostly LTE CAT-M1 really has global coverage. So it uses the same 4G infrastructure as you use, or like this, as almost anyone uses with their phone. And therefore it's really a global standard. And LTE-M and narrowband IoT, those are younger. They're only a couple of years old. And actually the cell towers that support 4G, they require software update to support these technologies. And not everyone around the globe managed to do that already. But we still see that there are already 110 operators that are supporting LTE-M and narrowband IoT, and this is actually rapidly increasing. So if you're centered around the big city, and definitely in Western Europe and in most parts of the US and Israel, you are actually quite safe with accessing these technologies. And so one part is, of course, the operators need to support these technologies, and at the other end, you need to have the IoT modems supporting these specific technologies. And there are tons of cellular modems that you can choose from. And it's more or less similar on how to instruct these modems. And it can be done via IT commands. And it's a more or less standardized way to instruct cellular modems on how to behave. So think about scanning networks, connecting to a network, sending data, entering sleep modes. So that can all be done via standardized instructions. And we'll demonstrate how this works in a bit. And yeah, most important is that there's a host, which is your PC or an MCU that sends the commands to the modem, and the modem always responds. So you can always validate if you properly manage to connect to these modems. And then IoT platforms. So how do they fit in this IoT solution? So it often starts, most of the IoT applications start with an end device. And most of the time, this end device initiates the communication and sends data to the cloud. And then the first goes to what we call eNodeBs, which are the cell towers of local operators. And they forward the data to Monogoto. In Monogoto, we run the core network, so making sure that the data is routed to the right place. But it also is responsible for all the device management, allowing you to manage devices at scale. But you don't want to end there, because eventually you want to store and visualize and act on data. And specifically, this part is what IoT platforms can take care of. And this is then only one part of the chain, because eventually you want to close the loop, and also you want to trigger alerts that are sent all the way back to the end device, because you don't want to be somewhere personally in the middle, and you want to automate this whole system that you eventually run an automated IoT system. With this far the introduction. So David, maybe you want to enlighten us on how this works with Ubidots.
Awesome. Thank you. Thank you, Lawrence, for your introduction on IoT cellular. I always have some troubles understanding the historical trace, and your briefing is actually very useful for me just to get some more information. Now into, IoT platforms. So I will base, of course, and I'll be talking about Ubidots, but you will find many providers out there in the market, right? All of them probably are based or are actually trying to solve one problem: how to build IoT solutions without the hurdle of hiring a software engineering team or taking years building your own solution. That's why IoT platform exists, and you'll find many in the market. A few points worth thinking about Ubidots that we offer in our toolkit. You'll find the ability not only to send the data or maybe retrieve it from your devices, but as you can see in the image, you have dashboarding capabilities with white label functionalities. So of course, we don't want you to offer a solution based on Ubidots. We want you to offer a solution based on under your own look and feel brand. Attached to those functionalities, you will find things like data-driven events. Lawrence mentioned something about it, and it's basically, for example, if the temperature goes above certain threshold, then you will need to trigger an event. And that event can be an email, an SMS, or even connect to third-party services through HTTP webhooks, you name it, right? You will also find in IoT platforms, also in Ubidots, user management and more or less analytics. It depends on the platform. So my message here, apart from being from Ubidots, is that there is a great variety out there, and based on your requirements, you will need to choose one that fits your application needs the most. Can we go to the next slide? Thank you. So we made a little exercise yesterday, and I found it really interesting. It's being long since I did it. So we built an IoT application from scratch using Monogoto's look and feel brand, as you can see it in the dashboard. We created an account in Ubidots from scratch and then branded, as you can see it, right? It's Monogoto, and we actually use something called plugins, which allows us to take data from an external API, in this case, Open Weather, and plot it as data into our dashboards. You see their temperature, humidity, and even some rows charts that plot wind speed and wind direction. All the way to the right, we put some controls. That's something we will look into it in the demo session. But what I wanted to show you here is that we took a day, and we understand that it might take some more time for you, as the learning curve is not the same. I've been working here a couple of years, but the point is, in a couple of weeks, with some time and effort, you will be able to get your application up and running within an IoT enablement platform, be it Ubidots or any other. Let's go ahead. And then the third portion of our session, which is actually diving deep into the TCP protocols. This is really important. We will be addressing UDP, TCP, HTTP, and MQTT. This is very important for IoT applications, specifically for cellular-based applications, because no protocol is the right solution for every application, right? You sometimes need real-time polling data from the server, or actually receiving updates in real time. You will need to reduce your data payload or use security protocols. That all fits into the mix of choosing the correct one. So let's start by mentioning some key features of all of these protocols. So abbreviation, Transport Control Protocol for TCP. This been with us, the whole time. This is the highway through which data is sent to the cloud or to the devices. Actually, HTTP and MQTT, they both run under TCP, okay? Then we have HTTP, which stands for Hypertext Transfer Protocol, and we all know about this protocol because it's what internet browsers runs upon. And MQTT, this protocol was specifically built for the IoT. It is lightweight, it allows PubSub, we will see it in a minute, and it stands for Message Queuing Telemetry Transport. On the architecture side, we have two separations. The TCP and HTTP runs on request response model, which is the basic client-server interaction where the clients query data or send data to the server and wait for a response. Here it's important to say that in terms of UDP versus TCP, the first one doesn't wait for any response, and that comes with some benefits. The first one being less response time, and of course, less data usage. And remember, if you are cellular based, then we are taking care of that because yeah, at the end of the phone, you don't want to get a surprise for data usage. And the second architecture is pub/sub model, which is the MQTT. Particularly important to note is the subscription, because it allows devices, which are the clients, to connect to a broker. And if anything happens up there in the cloud and they are subscribed to those changes, they will receive it immediately. So you can imagine this is being useful for control applications. Let's move really quickly into the complexity, message size, and header size. This all relates to the amount of data used by the protocol, or how long does it take to build an application using these protocols. So in terms of complexity, TCP is the easiest one. It allows a lot of flexibility for users. They can create their own data frames, but that also comes at a cost when connecting to servers. For example, I will use Ubidots, so you will need to send data in a specific data frame, right? Then the HTTP is rather complex because, as we will see in the demo session, it requires a lot of structure, and that comes very difficult when programming firmware. Luckily, there are many libraries or AT commands that abstract that complexity and have made connecting through HTTP a little bit easier, although there remains some difficulties. And in the middle range, MQTT. In terms of message size, so the most efficient one is MQTT because it usually uses binary data. Then it follows TCP. Here is important to note again the difference between TCP and UDP. You will, hey Lawrence, sorry, I'm sorry I'm interrupting. I saw a comment. I don't know, Lawrence, if you can take a look. Can you hear me okay? I'm sorry, I just want to make sure I'm not transmitting.
Yeah, okay. The quality is still good. Yeah, please go ahead.
Okay, awesome, thank you. So message size, remember, TCP versus UDP. UDP doesn't wait for an answer for the server. Those clients just send the data and they don't care about it. So that reduces data usage in terms of connection and network. And HTTP, because of the structure and because it was a protocol built to have like greater bandwidth, it wasn't designed for resource constrained devices or cellular networks. Okay, header size, quickly, TCP has none, HTTP is a large header, and MQTT is quite small. It can be as small as 2 bytes. And in terms of TLS, all the protocols, including UDP, can run on TLS in case you need to send your data encrypted to the cloud and protected from malicious people just, sniffing your network. Let's go again. Yeah, thank you, Lawrence. So I prepare a little table with features that are actually thought around IoT solutions. So the first one will be lightweight of the protocol, server response, pub/sub, extensive client-server interactions, and low battery consumption, right? These, I think, fit very well when talking about cellular networks and IoT, constrained device resources, okay? So lightweight, as we already said, TCP and MQTT are the lightest one, being UDP, the ultimate champion because it doesn't wait for any answer, okay? Server response, TCP and UDP implemented. We should remove UDP because by the protocol standards, it doesn't uses any server response. And in terms of MQTT, I would like to clarify something. It does have a response from the broker, but it's just divided into 5 categories that I'm not going to explain right now. It's not the point. And sometimes they are not very useful. So you sometimes fall short confirming the data is received. You will need to actually rely in something from the MQTT protocol, which is called QoS, quality of service. right? Then pops up TCP, UDP, and HTTP lacks that ability. They cannot do that, only MQTT. And let me just repeat that again. MQTT is the by default protocol when you're trying to get real-time updates from the cloud down to the devices. Let's move forward to extensive client-server interactions. The champion there is HTTP. So if you are looking forward to getting your device interacting beyond sending and retrieving data with the server, it is probably the best option to choose HTTP, because this protocol is actually built around providing many actions through their methods and different paths. And low battery consumption, I'm sure that previous talks with Lawrence and other invites address this topic. So TCP, UDP, and MQTT, because of the low data usage, fast response time, and connection recycling, they champion in this category. It is worth mentioning that, I was actually adding a few comments that HTTP, as the connection is larger, then the radio stays more time turned on, and hence it is not very battery oriented. Let's go. And at the end, we will start with our HTTP demo. Please let me just advise you that we are going to do two things: send data to Ubidots using HTTP and getting data to Ubidots. So let's start with posting data. As I told you, as actually the word suggests, a protocol is just a specification of how data should be sent from the client to the server, right? So in this case, if you focus on the middle ground, you'll see there is a structure, a really defined structure, which is post, the type of method, the host, custom headers, and then the payload. Everything that is pink are variables that you will need to change based on the specific server. So let's go all the way to the right and focus on how you need to change this to make it work with Ubidots. So the first thing you will see is that the method is post, which indicates that you are going to send data. Then the path, you can think it as a route that tells the server which action to execute once it receives the request from the client. Okay, in this case, as it is a post, and we are pointing to, at the end, you will read IoT device. That's the identification label within Ubidots. So you're telling the server, hey, I want to send data to this device. And the host is basically pointing to our API domain. And if you read through the next 4 lines, those are all custom headers. Let's focus on the second one, X out token. This is really important because it's the only way you can actually authenticate your request with Ubidots API using one of your tokens. Otherwise, we would reject the data. And very at the bottom, you have actually the most important thing, the data you would like to send. So think about it. All the things we said before, the actual payload is overhead from the protocol. So very data consuming. I will give the mic back to Lawrence, which will show us how to actually execute this from the device using AT commands.
Thank you for explaining. So I've just built a small dashboard with Ubidots, which looks like this. And this is actually live. And what I'm trying to do now is I'm trying to send updated temperature, humidity, and pressure values. So let's try to do so and dive in. So what I'm going to do here is that I will open up the serial monitor, which is the interface allowing me to send AT commands directly from my laptop directly to the cellular IoT module. And for this demo, I'm using the Sodak Sara dev kit, which is an Arduino compatible dev kit. It's quite easy to use, and it uses the u-blox cellular modem. And So I flashed it with firmware, allowing me to directly interact with the modem. And as you've seen in previous versions, once we start interacting with any IoT modem, then we always start sending AT and we wait for the response from the modem. And if it says okay, then we're certain that we have established a connection and we can move on with the configuration. So I already set up the APN settings, and to double check, we can validate if it actually has an active connection running. And you see here that's connected to KPN, the Dutch operator, and the 7 indicates that it's using LTE M technology. And sometimes I also do a final check using this command to see if the device actually has an IP address, because if it has an IP address, then it means that it is properly connected to Monogoto. So with that said, let's dive in. And as David explains, it all starts with the Ubidots base URL, and that's industrial.api.ubidots.com. So if it goes too fast, don't worry. I create a write-up that I will share directly after this webinar, so you can try it out yourself afterwards. So we have some custom headers. So the first one is my authentication token, and the second one is the specification of the content type. And in this case, we're using JSON data. And this is more or less what we need. So we actually don't need to specify the number of characters that we're sending, because the modem will do so by itself. There's one thing that you can keep in mind, and that is that when sending data, it's quite common that you actually store the data in a variable or even in a specific file, and you send the contents of that file to the cloud. And we're gonna do the same as well. So here I'm using kind of fake data, something that I made up myself. So temperature, humidity, and pressure. So it's not real sensor data, but we'll dive into that part later on. So we now have a file created. It's called sensordata.json, containing 49 characters. And to double check if it's set correctly, I'm going to read this specific file, and it indeed says that it has 49 characters, and this is the content of that JSON file. So we set the base URL, we set the custom headers, we have the sensor data, and now what needs to happen is sending the actual data. And it happens with this AT command, where we specify the URL path. So before I created the device in Ubidots, that's called IoT device. This is the specific URL. I specify a response file. So it actually gets the server response and stores that into a file, so I can review that later. And I'm sending the sensordata.json file. So let's see if that's working out well. And I already see that the last digit is a 1, which should indicate that everything was sent correctly. And to double check this, I'm opening this data.txt file and visualizing the server response. And here we see directly that there's a 200 OK, indicating that the message has been properly sent. And what you also see here, that all this data is also being sent over the air. So as David explained, there's a lot of overhead when using HTTP. And if you're simply using UDP, for example, then it only sends data and it does not show you any proof that the message actually arrived, but that also that removes all the data that you see here, and it does not require all the data to be sent. And now the big moment, to see if actually the data has been updated. And as you can see here, the values have just been updated a second ago, and it have been updated with the latest sensor data that I just highlighted. This far, the HTTP post. demo. So back to you, David.
Okay, that was fairly easy. I hope all of you think the same. Definitely, I just would like to reiterate on a comment. Many AT comments, as have you seen there, actually abstract many logic. If you remember, I would like to tell this comment is we never had to set the content length header, which is mandatory for every HTTP request. This is something that the AT comments do on the background. They just measure the length of the payload and assign the content length automatically because you are making an HTTP request. That's a nice detail from manufacturers to make developer lives easier. So with that being said, let's just follow up with the server to device section. That is getting data from Ubidots and act upon it from the device. So I won't spend so much time explaining the structure because you will notice right away that it's very similar. A couple of things to note. The first one, and I would say the most important one, is the change of the method. Instead of a post, we are now having a get. That means we are requesting the server information, a specific information from the server. And the second thing that changed is the payload. We no longer have a payload because we are not sending data to the server. Okay, so I will spend 1 more minute explaining like a human explanation of the path. The path is that you see called API version 1.6, then devices, and then first of all we have the IoT label. Device label, which in this case is IoT device. Remember, this is how Ubidots recognizes the device in your account. And then next up we have the variable, which is in this case is called, or it's labeled actually button, right? And at the end, all the way to the right, we have LB. This stands for last value. So if we read that first line, we are telling the server, hey, please get me the last value from the button variable inside the IoT device. That's how you can interpret that path. And the rest is basically the same. The host, the user agent, and of course, the authentication header named XAuth token equals to a token from your account. Very simple. There is not much to say there. I give it back to you, Lawrence, to show us how this works with AT comments, and then something even nicer.
Great. So back to our dashboard. So you see here that I created a button, and what we do is we query the button state, which is either 0 or a 1, whether it's on or off. And we go back to our serial monitor to directly communicate with the modem. So we already, in the previous example, we already set the base URL and the headers, so we don't have to go through that phase again. And that means that I can directly send the HTTP GET message. And again, here we specify the URL path. And as David explained, so I'm targeting the IoT device with the variable button, and I'm requesting the last variable. And what it does is it stores the response, so the server response, and this time I'm storing it in a different file, which we call response.txt. So let's try it out and send it out. And now let's have a look at the response.txt file to see what it does. And again, we see a 200, which means that it has been successful. And here, if you look at the bottom, then we see 0.0, indicating that the button has turned off. Now the big demo starts. So I'm turning the button on, and then we're gonna see if this would actually update the server response. So again, I'm sending the HTTP GET message, and if all goes well, then we can again find the server response. And as you can see here, there's a 1 instead of a 0. So hopefully this more or less explains the basics. And as long as you know the AT commands and instruct the modem at the right time when to execute it, it's actually I would say, relatively simple. And there are a few more AT commands that I'm only quickly showcasing here. So for example, if I use this command, then it actually shows the amount of characters in this response. So that's 174. And if I zoom in to only the variable that I'm receiving, then I need to start with the 171st character and basically count three characters, and then that would give me the exact character that I want to use in my application. This far, we've only been programming the modem manually, but this is of course not how it works in real life. So normally you have a program that runs on your end device that at specific intervals sends AT commands to the modem, instructing it to send data wirelessly. And I did the same. So I created a small Arduino sketch that sends the battery value, the voltage every 20 seconds. And because there's an accelerometer, I can shake the device to initiate a trigger. So when I shake it, it sends an HTTP GET message to retrieve the button state. And based on the button state, I want to turn the LED, the onboard LED, on or off. So I prepared this Arduino sketch, so I will show you how this looks. And well, I have the board with me, the Solek Sara development kit, and I'll start with uploading the sketch to this device. And this might always take a few seconds, so let's give it some time. And first need to select the right port. Let's have a look. Okay, there we go. And uploading the sketch. Let's give it some time. And there we go. It is uploaded. And then I'm showing you the serial monitor showing that it's automatically sending all these AT commands to the IoT modem. And this might always take a few seconds before it boots up, before it attaches to the network. So let's give it a little bit of time. And there we go. So it's connected to the network, the setup is done, and it already started posting HTTP messages. So we can look again at our dashboard, and here we see that the latest value has been sent over to this dashboard. And now the trick is that if I shake it, then it will retrieve the value of the device. And I will give you a live demo showcasing how this actually works. So as you can see here, the device, the LED is turned off. And if I shake it, then you should see that an alert is triggered and it reads the button state from the dashboard, and it showcases that the LED is off. Okay, so now when I press this button and go through the same procedure, so I'm gonna shake the device and that should trigger an alert, as you can see, and I'll show you in front of the camera. And you can see that the LED starts lighting up. And also here you can see that the button state changed to 1, highlighting that the LED has been turned on. And finally, we can again change this around. So I'm pressing the button again. And then if I shake the device, it should initiate an alert. Let's try that again. There we go. There's the alert. And then the LED again turns off. So far the demo. I'll be sharing the Arduino code to the Monogoto forum. So you are free to try this out yourself at home. And in fact, it's more or less what we did manually, but then I structured the sketch in such a way where I initiated either a time interval or an trigger based on the accelerometer to initiate an action, which is either an HTTP post or an HTTP GET. And before we, there's one more thing that I would love to explain, which is something about Monogoto itself. And Monogoto, as I explained, is a virtual operator, meaning that we take care of the full virtual part of IoT connectivity. And it means that we run the virtual network component, making sure that we route the data and manage all devices, and we roam with existing local mobile operators. So we have roaming agreements with about 500 networks around the globe. And that means that if you have one SIM of Monogoto, which can either be a plastic SIM or a hardware SIM that you solder onto your board, you directly access, you can directly access all of these networks around the globe. And apart from focusing on connectivity, like one of the biggest goals that we have is to simplify the IoT developer life. And it means that we have an intuitive console allowing you to manage your connections either individually or within groups. And you can define integration, alerts. And the beauty is that everything is API driven. So you don't have to actually use our graphical user interface, but you can, instead, you can, if you like, completely integrate our platform into your own platform of choice. And finally, there are some more advanced features. For example, setting up a VPN, allowing you to set up a secure tunnel from your device to the cloud platform, and really boosting the security of your IoT solution. And thus far, we've only been focusing on public networks, meaning that you have a SIM and you connect your device to any public mobile operator. But what we see more and more is that we also have private networks. So we can support you for, let's say, setting up a private network in a warehouse, for example. And that means that while you're in your local vicinity, you can use your private network. And that means that you have access, you have control over the quality of service and the level of security. And let's say once the trucks leave the warehouse itself, then it can start roaming with these public networks. And combined, that will give you a hybrid LTE solution. So if you'd like to learn more, then these are the places to go to. So we have an active forum. We have an active forum for you to discuss anything with like-minded people or with Monogoto experts. We have a documentation section with very much detailed information. That would almost conclude this workshop. David, maybe you can explain us, if people want to learn more about Ubidots, where should they go?
Yeah, definitely. Thank you. Well, the easiest way is actually going to ubidots.com. That's our page. And then you will find the option to create a 30 days free trial. You will have access to all of our features. And then you can also reach out to us at partners.ubidots.com, asking for a $50 bonus out of this webinar. So that makes it for a total of 2 months. And from that point on, if you want to continue your journey, you can either upgrade or even use our free service called Ubidots STEM. So basically the invitation is just sign up and reach out to us. You will find us also at support.ubidots.com.
Great. And if you would like to get started with Monogoto itself, then we can easily provide you with a free evaluation SIM. So how to do so, you can just drop me a message on the forum or by email, or you can fill out the form on our website. You can just go to monogoto.io and you can request a free evaluation SIM, and it directly gives you access to our development portal. Let's first have a look at some of the questions that are coming in.
Am I able to ask you something, Lawrence?
Please go ahead.
Yeah, thank you. So it's not so related to the modem or Monogoto. Actually, it's related to Monogoto. I'm sorry. I'm curious to know how the change between a 5G private network and the switch to a public one works. Is that completely transparent from the user, or is there some other things needed to be done?
Yeah, good question. You can, this is again, like the more you dive into these AT commands, the more you learn about the functionality. So you can set the order of the operators that you want to connect to.
Oh,
and it means that if you set up a private network, then you would have a unique what's called MCC-MNC, which is the unique operator code. And so first you can start connecting to that specific network. And if it's available, then it directly connects there. And if you do a network scan and that network is not available, then you can basically have a fallback network, or you let the device do a scan and connects to the network that's most with the best signal.
Okay. Thank you. That makes perfect sense.
So we see a question coming in here. So which protocol is used most frequently? David, do you have any idea what's most popular within the Ubidots platform?
Wow, interesting question. Well, I must say that, let me think about how I think of that question nowadays, because there are many other protocols apart from the ones we addressed today that also adds to the balance. So if we stick to cellular, I would say MQTT and TCP, right? Because of the data usage constraints. Yeah, TCP and MQTT because of the data usage. Those that I think is the most frequently used protocols in cellular based networks. If we then move to other types of solutions, well, the question opens up again, and you need to think about it. One thing aside that is that there is no key that fits all locks. So again, you will need to just take advantage of the protocol and just make peace with some of the disadvantages. But yeah, basically TCP, UDP, and MQTT for cellular-based networks.
Yeah, and what we've seen last week when Sodak did this presentation, so their preference was actually UDP, mostly because the reason that we explained that this is the lightest weight of the protocol. There's very little overhead, and it does not require a server response. So this is really the fastest and most effective way of, or most efficient way of sending data. And of course, that depends on the use case, whether this also applies to you. Great. Well, thanks, Janset, for your appreciation for this workshop. Great to hear. So hopefully everyone learned a thing or two throughout today, and as well as throughout the other workshop series. Any other advice you want to give the listeners, David, before we are going to conclude this session?
Well, I would like to invite you again to start your IoT journey as these sessions suggest, either to the cellular networks at Monogoto, which I believe is a great product. And then also, if you have questions about Ubidots, happy to address them. Just reach out through that email, and yeah, happy to help you navigate the IoT stack, which is really, really wide and spread. So that will be my final comment.
Perfect. All right, thank you so much. Again, for everyone, yeah, I would definitely agree there, and I would say just start trying out how it works and start playing around with these different protocols and see what works best. Because similar to the HTTP demo that we gave, there's also kind of a very a defined set of instructions to send data using UDP or MQTT. And kind of, if you know the AT commands, and if you have like a specific endpoint, for example, Ubidots or any other IoT platform, the communication is actually quite easily established. So thank you so much for listening. Have a look at our forum there. I'll share some screenshots about the demo, and I would love to see you all on the forum shortly. And thank you so much. We'll see you soon.
Thank you. Thank you, Lawrence. Have a good one. And thank you, everybody. Bye-bye.